Hey guys, Mr. Riz here to help you out on this next notes here. So what we're doing is just basically learning some vocab about polynomials, making sure we understand, what a degree is, what does the terms mean, and the leading coefficients, and how does that affect the end behavior of a graph. Okay, so we got some vocabulary over here on the left side. So terms are what are separated by the plus or minus sign. So if we look at each one of these examples here, we can see this first one has 1, 2, 3, 4, 5 terms. And since it has 5 terms, we would just call this a polynomial. I'm just going to abbreviate here just because I'm kind of running out of space. All right, just let's stick with terms. Okay, this has 1, 2, 3 terms. All right, so it has 3 terms. We call that a trinomial. All right, number 2 here, we got 1, 2, 3. That also has 3 terms, so that is also considered a trinomial. And this one has 2 terms, and 2 terms, if we look, is a binomial. Okay. Now, if we look, next is the degree. The degree is going to be the largest exponent of the variable. So if we look here, all right, this x has x to the 5th. That's the highest one, so this is degree 5. And if it's a degree 5, that is called a quintic. Now, there are degrees higher than degree 5, but we pretty much won't go any beyond that in this class, like in this next chapter. All right, this one, degree 3 here. It's the highest exponent we see. Degree 3 would be a cubic. Okay, this one over here is also degree 3. So that would also be a cubic. And then this one here is degree. Well, we just have an x, and that's technically degree 1. We look, and that would be a linear function. Okay. Now, the leading coefficient is going to be the number in front of the term with the largest degree or the largest exponent. So look here, x to the 5th, it has a -7 in front of it. So the leading coefficient is -7. It's not the first number we see. It's the number in front of the largest term. We're always kind of assuming that we're going to put this in descending order. All right, this one over here, we got their x cubed that has a 6 in front. This one over here has a 4 in front of its x cubed, and in front of this one x is a 3. Okay, so why don't you go ahead, pause this video if you're watching this, try this one on your own, see if you guys can go ahead. All right, let's see if you got it right here. All right, how many terms are there? There are 3 terms, so this is a trinomial. Got more room, so I'll write it out. Hey, morning. All right, we got degree. He said he was in there, and I think he said he was going down to the ACT. Is he not in there? Yeah. Thank you. He's a good kid. All right, degree 4 here. And so that would be a quartic. And the leading coefficient in front of that is a -3. Okay, so kind of basic vocab. You probably have heard these things. Now, what does that matter? Now, based off of the leading coefficient and the degree, whether the degree is even or odd, and whether the leading coefficient is positive or negative, we can go through and actually determine the end behavior of a graph. So let's take a second here, and I'm going to split screen so I can open up Desmos. And I'm going to try to do just real quick sketches of these graphs here. All right, so I'm just going to go here, just drawing a couple T's here. And let's write out what the degree and the leading coefficient is for every single one of these here. Alrighty, so graphing calculator here. Let's do first one. We got -2x squared plus 6x plus 12. All right, so that looks like an upside down parabola. I'm just going to add that into our sketch of our notes here, like that. All right, next one. Let's change this up here. We got 4x to the 3rd plus 6x squared minus 2x plus 5. Okay, so that goes up and then wiggles and comes all right, up, wiggle up. Okay. Next one we got, let's see, just making quick sketches of all these graphs here. And then we're going to kind of look to see what do we notice here, similarities and differences between all these. -1. So, okay, kind of the opposite of the last one there. So it's going to go, okay, and then last one here. We got 5x minus 2x squared plus 4x to the third plus 6x to the fourth. Okay, kind of like a parabola. A little wonky right there, but okay. All right, so if we look here, let's now go back and look at all the degrees of each one of these. Okay, this is degree 2, so we would say that's an even degree. And the leading coefficient is a -2, so we'll just say it's negative. We're going to be just as general as that here with this end behavior. Okay, this one here, it is degree is 3, so that's an odd number. And 4 is in front of it, that's a positive leading coefficient. This one here, degree is 5, that's also an odd degree. The leading coefficient is -2. Okay, so that's an odd negative. And then here we got degree, okay, 4, so that's an even degree. And the leading coefficient is 6, that's a positive. Okay, so if we look at these here, we can kind of find some similarities. We look at both the even degrees, the negative and the positive ones, they both start and stop in the same spot. So this starts at the bottom here, ends at the bottom. It's pointing down, ends down. So we got a down and a down. Over here with the even, we have an up and an up. Okay, or the even positive, we have up and up, which kind of makes sense. Positive is above, negative is below. Now with the odds, they go in opposite directions. We have down, up, or we have up, down, which that kind of makes sense. A positive slope starts at the bottom and works its way up, goes from down to going up, and a negative slope goes from up to down. So that means if we change our function or we have a different function, we can determine how the graph is going to end on the left and right side. So like if we look at this example here, if I just change the leading coefficient to a -6, it just flips our graph. So now it's going to be down and down. Okay. Or if we go back to being positive, we change that to an odd degree. Okay, it's going to go down then up. All right, and if I make it negative odd, it goes, okay, up to down. So we can determine the end behavior of the graph just by determining whether the function is even or odd. So once you pause this video, try this on your own. Find out the degree of whether that's an even positive, even negative, odd positive, odd negative, and then determine the left side and right side. And try to sketch the graph real quick without using your graphing calculator. All righty, so let's take a look at this. All right, this degree here is degree 3, so this is an odd positive. So odd positive. On the left side, the graph is going down. On the right side, it is going up. So if we're going to sketch this graph, we know on the left side, we have an arrow going down. On the right side of our graph, our arrow's going up. So something's going on in the middle here. We don't know exactly what yet. We will determine those things later on. But it's going to be something like that. It could be a straight line. It could wiggle, waggle. We don't know, but we know where our arrows are going to be at the end of our graph. Okay, next thing, let's talk about mins and maxes. Okay, so minimums and maximums here. A minimum is any valley in the graph. So there's no limit. So we can have a graph of like literally hundreds of minimums. So anytime there's a dip in the graph, the low point of that is called a minimum. The maximum is the top point of a graph. Okay, so the top of the hill. Once again, there's no limit on it. Okay, so absolute minimums and absolute maximums is where the minimum or maximum appears the lowest or highest point on the entire graph. Okay, now this will only occur in even functions because odd functions will be going up
positive or towards infinity.
Relative mins or relative maxes are the lowest point in just a certain region. So they're the valleys or the mountains. Okay. So if we look here at this first graph, let's assume that these lines go down forever. All right, this first graph here, we can say, okay, we have a couple of maximums. All right, so let's make a list here. We could have absolute maxes, or we could have relative maxes. And we describe the location of those maxes by the x location. So I'm going to say 0, 1, 2, 3, 4, 5, -1, -2, -3. Okay, so if we were going to describe where the absolute maximum is, we're going to look to see where the absolute highest point on the graph is. And that's right over here. And so we'd say that there's an absolute max when x equals 0. Okay. Now, these other points here are relative maxes because if we just look in that region, they're the highest point. But like right here at -3, that's a high point on this mountain here, but that's not the highest point of the graph overall. Same thing with +3. Yeah, that's the peak of this little mountain, but it's not the peak of the entire mountain. Okay. Now, if we look the other way, if we look for absolute mins and relative mins, we could look to see the low points on the graph. And the low points on the graph are right there. Now, there are going to be no absolute mins because the graph keeps going down forever. So we can't say, like, we don't know. Is it at -5? Is it at -50? Is it at negative infinity? We're just going to leave it blank. But our relative mins, we could probably say here at like -1.5 and probably +1.5 as well. Looks like a pretty symmetric graph. Okay, now our zeros is where it crosses the x-intercept. These are also known as real roots. Okay, and so if we look, we have a lot of zeros. We have at least 6 of them here. And so we're just going to try to state our zeros, and you kind of go from lowest to high. So like, I don't know, that's like -3.8. I'm just taking guesses. We got -2. That looks like it's a little past like -1.2. Then we got a +1.2, and then we got a +2, and then probably another 3.8. Pretty symmetric part. Okay, so let's keep this going. Let's look at this one here. We have an odd function because it starts up high, ends down low. We know if it goes in opposite directions, that would be odd. And let's list the absolute max and the relative max. Let's also do the absolute min, and the relative min, and let's name the zeros. Okay, so if we look here, absolute max and absolute min. Well, this is odd, and if we look, the highest of the graph goes on forever, so there actually is not going to be an absolute min or absolute max. Okay, graph keeps going down forever, but we do have a relative max, and I could probably say that it's at like 0.5, maybe at 1/2 here. And then there's a relative min, a valley, right there at like -0.5. Now the zeros is where does it cross the x-axis? Right there, and there. So I don't know, I'm going to guess like -0.8, and then probably right at 0, and then probably a +0.8. It looks very symmetric here. We're just taking guesses. We don't know the equation, so we're giving it our best shot. All right, so last part of this video here, if you guys want to pause this, try to look at these examples here. And I know it's kind of hard to see, but let's see if you can label all the mins and maxes, name them as relative or absolute, and then circle the zeros. Okay, so here we go. If we were just going to say, look at these here, we would say we have no absolute mins or maxes because these lines go on forever, just like in the last example. But we do have a relative max when x equals 8 and a relative min when x equals 6. All right, and I could definitely say zeros here. It looks like we got one there, one there, one there. All right, so that would probably be, if you just want to say x equals 5 for a 0, we can just say 5. That's a little past 7. And then we got a little past, so 7.1, maybe 8.5. I don't know. We're just taking guesses here. Now, this one here, if we look, boom, boom, those are our minimums. We got a maximum here. There is no absolute max, but we do have a relative max because our graph keeps going up forever. So that means we have no absolute, but we do have a relative max right here. When x equals, we'll say negative 2.5. That's probably a good guess. Now here we have the low point, and even though they are the same, these are both absolute mins. All right, because they are definitely the lowest point in the graph. The graph does not get lower between the two. We're going to argue that they're the same. I mean, in theory, maybe one is just like a tiny, tiny bit lower than the other one. That'd be a pretty hard equation to actually make up, or to do that, to be that close. But we're going to say both of these are the absolute max. You can have multiple things be the same. So at -4 and at -1. And then our zeros, I would probably also argue that these touch the x-axis right there. And so we could say that our zeros are also at -4 and -1. Okay, guys, thanks for watching. We got one more section to talk about with graphs, but we're going to kind of pause it there, and you guys have an IXL to work on. If you guys have any questions, make sure you ask. If not, thanks again for watching, and I will see you guys later. Well, let's stop this video. There we go. It was hiding.